Okay? So today we're going to be multiplying polynomials by a monomial. So we're going to multiply multiple things by one thing. Okay? So remember, just a review up here. So a squared times a cubed. Remember when we wrote them out. So a squared is a times a. And then a cubed is a times a times a. And it's 1, 2, 3, 4, 5. So our exponent became 5. And we realized we can add 2 plus 3 is 5. Remember when we learned that shortcut. Okay? So on our next one, okay, so 4 and negative 3. What do I still do with this 4 and negative 3? Multiply, because those are called what?
Numbers.
Coefficients. They are numbers, but they're called coefficients. 4 times negative 3 is negative 12. Negative 12. Then we have x squared times x to the 4th. So remember that's x times x, and then x times x times x times x, which gives us x to the 6. We can just add those exponents. We can skip this step because we've already learned this process. We can skip that. This should just be a review. All right, our next one, we have 5w squared y times 6w cubed. Well, what do we do with those coefficients? Multiply. We always multiply the coefficients if it says multiply. 5 times 6 is 30. Then we have w squared and w cubed. Remember, same base. We do what with their exponents? Add. So 2 plus 3 is 5. And does this y over here have any friends?
No.
No. So he's just going to go in the back and be exactly the same. He's not going to change. He has no friends. Okay. You have to have friends to change, yeah. Friends change you. That's why your parents, sometimes y'all come home and they're like, I don't like you hanging out with so-and-so. You change. Alright. So right here we have 2 cubed times 3 squared. Can we add these exponents?
Yeah.
Why?
No, because they're
No. Why no?
Because there's no coefficient. They're not coefficient.
There's not a common
Denominator.
denominator, not a denominator, it's a base.
Base.
Okay? So let's actually write this one out. 2 cubed is 2 times 2 times 2. Times 3 squared, which is 3 times 3. Well, 2 cubed, you guys know, is 8. 3 squared is 8 times 9 is, what did you say it was, Gavin?
I said 70.
I was doing like the 9. No, you just went that quick. You said the 5 what?
He's trying to.
I did 6.
You can't use the exponent rules here because they don't have like bases. That only works with like bases. I'm so glad you just listened to me. Yeah. 8 times 9 is what again, guys? Okay, so sometimes we cannot add their exponents. They have to have a like base. The base is the big number on the bottom. The big number is the
That was
base.
a coefficient.
It's to the side.
Huh?
Mine said it was technically suicide.
No. All right,
I
stop.
thought that was a coefficient. So you just don't add the exponents to it? No.
You have to have the same base.
You don't even put them into it?
No, because we got rid of them. We read everything out and multiplied everything. Okay? So, our general rule is when base variables are the same, they have to be the same, that's very important, then we do what with the exponents? Add the exponents. Okay, we have done that before. That's what we did with our exponent laws in our last unit. So we're going to apply them in just a different way. Gavin, are you listening to me? Because you're staring out the window. And then you tell me later that I didn't teach you this. Right? When multiplying monomials, what did we do with the coefficients? We multiplied. Our coefficients 5 and 6 here, we multiplied. So you multiply the coefficients, add the exponents of same bases or like bases. Okay. Okay, so we're just going to apply that to a monomial multiplying a polynomial. So we're going to start with monomials and binomials. So see, like there's 1 out here, and then there's 2 in the parentheses. 1 outside, 2 in the parentheses. 1 outside, 2 in the parentheses. So guys, what rule are we using? What property are we using? We're using that distributive property still, okay? We're using the distributive property. So we're combining distributive property with laws of exponents, and then we're going to see how it works out. So A has to multiply both A, and it has to multiply B. Okay, so we got to distribute. So A times A plus A times B. And then, guys, if we have an A times A, that's the same thing as A squared. Or again, what's the exponent with this A here? 1. And what's the exponent with this 1 here? 1. And 1 plus 1 is 2. They have the same base, so we can add their exponents. Okay? So let's try the next one. We have A cubed times A squared. So I'm going to write that out here first. So A cubed times A squared, because we're distributing to each of the terms. Then what sign goes in the middle? Addition, plus A cubed times what? AB. Now what is this A and B doing? Multiplying. So it's A cubed times A times B still. So right here, how can I simplify A cubed times A squared? A to the 5th. Why can I make it A to the 5th? They have the same base. We add the exponents. Okay? A cubed, A squared, 2 plus 3 is 5. Plus, well, I know there's a B here, but don't I have multiple A's? Okay? So this one is cubed. This one is to what power? 1. So I can put these together, and it becomes A to the 4th. And B doesn't have any buddies, so he's just going to be A to the 4th B. Okay, so his exponent stays the same. He's still 1. But we can just combine these A's since they're being multiplied together. So that's 3 A's, 1 A gives us 4 A's together. Huh? No, because it's separated by a plus sign. We can only add those exponents when they're being multiplied. These are being added. Yes, sir? Okay. All right. So let's look at our next one. So we have a coefficient this time, 4a cubed. So we're going to do 4a cubed times what? 1/2 a to the 2nd power squared. So we're doing this times the first term. What sign's going to go in between? Subtraction. So when we're being subtracted or added, we're not going to be able to do anything with those exponents in between them. So then we're doing 4a cubed. So 4a cubed again times, what's the last term?
Negative 2a.
2ab. I went ahead and took care of that minus sign so I didn't have to worry about it later. Okay. Now let's just look at the first part. 4a cubed times 1/2 a squared. What do I need to do with this 4 and 1/2? What's half of 4? 2. So the coefficient's 2. Then we've taken care of our coefficient. So a cubed times a squared. So the base is the same. So it stays a. And that 3 and 2 make a 5. So 2a to the 5th. I can combine everything here. Multiply the coefficients. Same base, so we add the exponents. Are y'all good with that one? Okay, then we're going to look at the other half. So minus, well, we have coefficients, 4 and 2. What do I need to do with that 4 and 2? 4 times 2 is 8. Okay, then I have an a cubed, and I have an a to the 1st power, so that's going to become a to the 4th. Does B have any friends? We just put him in the back. He has no buddies, so he's going to stay exactly the same in the back. You say this doesn't make sense or this makes sense? Okay. All right. Any questions? No. Y'all good?
Yes, ma'am.
Okay, so here's our distributed property rule. You guys know A times B is AB plus A times C is plus AC. Okay, and that's what we're using here. So let's go ahead and do our examples. These are a little bit simpler. So what do I need to do here? Multiply. Good. 3 times 7x gives us what? 21x. And then what's going to go in the middle? Plus, good, 3 times 5 is 15. So this is our basic distributed property, and that's what we're using here. Okay. The next one's just a little bit more complicated because we've added a variable. So 3b times 3b. 3 times 3 is 9. b times b is b. What?
Squared.
b squared. Good. Because that has an exponent of 1 and an exponent of 1. 1 plus 1 is 2. Plus 3 times 8 is 24, and we have a b attached. Do y'all have questions? Are y'all really okay?
No.
All right. Who wants to tell me the answer for C? Noah?
24 A squared minus 84.
Minus what?
84 A.
Y'all agree?
Yes.
Okay. Y'all good? Any questions at all? Okay. On the back. It's a little bit more complicated, but we're doing the same thing. So we still have a monomial out front, but now what do we have in the parentheses? 3. So a trinomial. So guys, how many times do we have to multiply then? 3 times. Okay, that's all that's changing. Instead of multiplying 2 times, we're multiplying 3 times. So 6y times 4y squared. So 6 times 4 is 24. Y times y squared gives us y cubed. Y to the third power, because this has 1, this has 2, that makes 3. Our sign is minus, so I'm going to drop down the minus sign. 6y times 9y. So 6 times 9 is 54. Y times y is y squared. Are y'all okay with me simply drawing the arrows and us multiplying that way, or do I need to write out the multiplication? Okay, y'all are good by the arrows. Okay, there's another minus sign. 6y times 7, so 6 times 7 is, and we have a single y, so it's going to stay a single y in the back. That's it. You're just multiplying 3 times. Okay, can y'all do B?
Yes.
Okay, y'all try B. Make sure y'all are good with that first. Gavin, are you done with B? Okay, that's what I got. Do y'all agree with me?
Yep.
Gavin, question.
Do you still multiply the coefficients if they don't have the same?
You always multiply the coefficients, yes. Because coefficients aren't bases. Coefficients are the numbers in front of a variable. The base, in this case, is A. Hi, Ryan.
Why would you multiply 5A times negative 4B squared? Why couldn't you multiply those coefficients?
So we would still do 5 times negative 4,
If it was a B?
even if it's a B, because those are the coefficients. We always multiply the coefficients. The coefficients aren't the bases. So you'd still do 5 times negative 4, and if this were, you said b squared, then it would be negative 20 a squared b squared. So you still multiply those coefficients, nothing changes with your exponents. Does that make sense? Okay. All right. So example 3. What do y'all think? What's going to change? There's just 2 sets of parentheses. Okay. So this one, what's multiplying the trinomial? 3. This one has a binomial, and so you're going to multiply by 6t. Okay, so first we're going to multiply by 3. So we're just going to do our order of operations. So 3 times 2t squared is 6t squared. Minus 3 times 4t, 12t. Minus 3 times 15 is... So that's just the first set. And then you're just going to do what's in the back. So plus 6t times 5t. 6 times 5 is 30. T times t is t squared. Plus, very good. So 6 times 2 is going to be 12, and the t is attached still.
The reason why you do it
Is that the answer?
No.
you get to add everything.
We have to combine our like terms. Very good. So we're combining our like terms now. So we have 6t squared and 30t squared. Say that again. Very good. So we have a minus 12t, a plus 12t. That's 0. So it goes away. And who is still over here by his lonesome? Minus 45. If you paid attention while I did things,
What's 6 times 2? What's 6 times 2?
What's 6 times 2?
Yeah.
What is 6 times 2? What's 6 times 2?
is there a t here? Here.
No.
No. So that's the same thing as t to the what power? The 0 power. Huh?
Gavin, it's just a variable.
You could, but it would still be x to the 0 power, which is just 1. You can make this whatever variable you want to. That's 1. But I'm just trying to show you, even though there's no variable here, it's okay. You could imagine there's a t to the 0 power. That's just 1. That's the same thing as not writing it at all. 6 times 2 is 12. T and t to the 0 is still going to be t because this is 1 plus 0, which is still just 1. It's like it's not even there because it's not. You'll ask me again in 5 minutes. It's okay.
It's like a disease. If you multiply it with the variable, that number gets the variable.
All right, on B. Okay, B is going to be a little bit trickier. The first part is going to be exactly the same. So we can ignore the back part. We can just look at that first part. So, can y'all do the front?
Yes.
Okay, so y'all do that, and then y'all are going to tell me what it is.
Can I do this?
Hmm?
Can I do that?
Okay, well, go ahead and do the front part. Just go ahead and do the front part first. So, Gavin, what did you get when you did 3 times 5x squared? What did you get? 15x squared. Well, did this 3 have a variable? You see where I'm going here? Okay, so you can do it if it looks like this, but if you have 3x squared times 5, that's when you have an issue. It's the same thing. It's the same exact thing. Good, but it's 15x squared plus what, Gavin? Plus what? 6x. Again, you multiply those coefficients and the variable's still just attached. It's the same thing. minus 12. Is everybody okay with that?
You know,
That's the first part.
Then
Then, on the back, what does this x have with it?
a negative.
A negative. So everything here is being multiplied by a negative x. So negative x times 7x squared gives us a negative,
7x cubed.
very good, negative 7x cubed.
I have heard
Negative x times 2x positive,
it's negative
2x squared.
And then
Are y'all okay with what I just said?
plus.
yes.
Very good. A negative x times a minus 3 gives us a plus 3x.
Wow.
Because x times 3 is just 3x.
I know.
Okay? Alright. So guys, y'all's homework is out of the book tonight. Remember, this needs to be able to be simplified. Okay? So tomorrow we'll go over the example 4 problems. Are y'all okay with that? Okay, awesome.